polynomials. We're 4 units down, 4 units left. But it's 3-unit tests because the polynomials, then logs and exponentials 1 unit, and then sinusoidal is another unit. So polynomials, we first started off with degree 1. We looked at these in grade 9 and grade 10. They're called linear. And they're in the form y equals mx plus b. And why do we call them degree 1? Because it's x to the 1. Okay. If we looked at the function y equals 2x plus 3, and we went to draw it, do you remember anything about that equation? Y equals mx plus b, what any of them stand for? Yeah. Yes. So the b at the back, the number at the back, it's also called the constant. This is always my y-intercept. What's cool about that is the constant no matter what degree it is. So the constant you can only look at if there's like no brackets, if the whole thing is expanded out and all the terms are collected. The constant at the back, the number without a variable, that's why it's called a constant, because it remains constant no matter what I fill in for my variables. It will always be my y-intercept. So this, the constant, the b, is always my y-intercept. So if I ever asked you for y-intercept, it'd be very easy to just pull it off of there, right? Wouldn't have to do any work, wouldn't have to graph it or anything. Okay. So we go to draw it. When we go to draw this graph, we always do the y-intercept first. Because slope is what the other one is. The slope is the rise or the run. So you have to have, like, you have to have a point to rise and run from, correct? So a lot of people want to do slope first, and then they just rise and run from 0. Was there a point at 0? No. 0, 0, there's no point at 0, 0. You can't just start rising and running from no point. If you want to rise and run, you have to do it from a specific point. So that's why we have to plot the y-intercept first so that we have somewhere to rise and run from. Okay? So we're going to plot the y-intercept first. We're going to go to the y-axis and we're going to put the 3. Okay? I know my slope, which is my m, is 2. And I need it to be over something because I rise and run. What's it over? Over 1. Now this is a positive slope, isn't it? This is also called my leading coefficient, you guys. In this is my leading coefficient. And my leading coefficient is positive in this case. That's great that it's 2, but it's positive. And why is it called the leading coefficient? Because it leads the equation. Why does it lead the equation? Because it's the number in front of the largest exponent. Okay? So your leading coefficient is the one that leads the equation, and coefficient is just the word that means in front of. So if it's a coefficient, it's the number in front of the variable. The leading coefficient is the one that leads the equation, so it's the one in front of the largest exponent. Okay? It only has one exponent in this one, so 2 is always going to be your slope. In this case, can be your leading coefficient. And it's 2. Now remember, people are like, do I run or rise? Do I rise or I run first? Well, think about it if you're in bed and you want to get to school. If you're in bed and you want to get to school, if you run before you rise, are you going anywhere? You just look foolish. You're running in your bed. It's super weird. Don't do it. You're also late for school. All bad things, okay? If you want to get out of bed and go to school, what are you going to do first? You're going to rise, and then you're going to run because you're late. So that's what we're going to do. We're going to rise before we run, just like you would in the morning. It's a +2, so we're going to rise up 2, and then we're going to run 1. So people are like, oh, I just rise left 2. I'm like, how are you rising left? You're just You're just moving. And then they're like, I'm running up 3. Like, where are you going up some stairs? Like, what are you doing? So running is horizontal because that's how you run. I don't know if you know this. And when you rise, you're going up or you're rising down, which is super weird, but nonetheless, yeah, okay. So we have to have a point that we go from. We plotted the 3, our y-intercept. We're good, right? Then we're going to rise up 2 from it, 1 to the right. Up 2, 1 to the right. Now it's as if I've kind of ran off of my graph, correct? So sometimes doing the rising and running that it says, you're actually at the very top of your graph and it tells you to rise up 2 and run 1, and you're like, I have to extend my graph. But it's a graph that's already drawn. Well, no, you could go the opposite direction. But you have to do the complete opposite to go the opposite direction. Because if both of these were negative, a negative divided by a negative is actually a positive. So that's why if you do the complete exact opposite, you're also going to get a slope that lands on the line. So instead of going up 2, right 1, I could go down 2, 1, 2, left 1. Down 2, 1, 2, left 1. And what do I have? The same points on the same line, correct? Okay. So we know that our constant is our y-intercept. We know that our leading coefficient is positive. The leading coefficient tells you how you end on the right. So this one is a positive leading coefficient, and I ended up. We agree? So that's how we end on the right. So I have a positive leading coefficient, which means I end up on the right. And because it's a line, I must be ending down on the left, correct? Because these have to end up one or the other. They have to go one direction or the other. Also, it's a positive slope, so you knew it would be going up, right? But we're not just looking at linear equations. The leading coefficient will always tell us how we end on the right, no matter if it's linear, quadratic, or cubic. Okay? So if it's positive, we end up on the right. But because it's linear, we end down on the left because they're in opposite directions. Okay? And our constant is always our y-intercept. What's my domain? What's my domain of this graph? What x values are on it? Everyone should be paying attention because it's new. Or it's old, but you don't remember it. Domain is x or y? X. Domain is always x. Also, someone may have told me this and I like it. Domain x, no lines underneath. Range y, both have tails. Yeah, it's real. It works. Okay, so domain is x. We agree? Okay, so it's all the x values that exist. So we have a graph that goes like this. We agree? So is there any x values on that graph that don't exist? Like 0 is here, -1's down here, -2, -3, -4, -5, -6, blah. And then all the x values positive. 1, 2, 3, 4, 5, 6. Can I find a x value on that graph for every x value? The only time you can't is if it was like something like this. If there was a graph like this, x would start at -3, but there's no other x's this way, is there? We agree? Does this graph have that problem? If arrows are going in opposite directions, you for sure have XER. But you also have YER as well. You have all the X's and you have all the Y's. It's going on forever up, it's going on forever down, it's going on forever left, it's going on forever right. Okay? So the great thing about linear graphs, unless it's a word problem, because word problems can restrict your domain, because say it was time, you can't have negative time, right? But if it's not a word problem, your domain is XER, YER. And you have to write it like this. If you're like, I'll just write XER, you're not writing it properly. These little squiggles are there for a reason. The squiggles mean the set of. This is the set of numbers. Y is the variable, such that Y is an element of the real numbers. So that means every real number exists on this graph for Y. So you have to write it in that format. Okay? Basically, if your arms can do the disco, you have XER, YER. So a cubic function is going to look like this. It's going to go won't, 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 but you're still going to have arms going out at the end. If you have arms going out at the end that can disco, you have XER, YER, unless it's a word problem. Okay? So arrows going in opposite directions, up and down, XER, YER, always. Those are the best because you don't have to really think. You just write. Okay? Unless it's a word problem, then it could restrict. That makes sense? So I'm going to give you an example to try. I want you guys to graph y equals negative 3x plus 4. I want you to graph it. I want you to tell me the leading coefficient. What it tells me about the graph. The y-intercept. The domain. And the range. Zoom 6, standard. So we're going to go to y equals, and I'm going to clear this out. And we're going to go xt theta n, to the power of this little hat symbol here. Mine pops up. If yours doesn't pop up, that's fine. You'll see a little roof symbol like this. And down here it shows my steps. I pressed xt theta n. I pressed this button. And then I'm going to press 3 and enter. Okay, so I have my y1. Then I'm going to go zoom. And for those of you who have always like had to change window to negative 10, 10, 1, negative 10, 10, 1, if you press zoom 6, this one here, it sets it to that window. So if you change your window, we're going to go zoom 6, it sets it to the negative 10, 10 window for you. If I press window, I'll show you. See, negative 10, 10, 1, negative 10, 10, 1. So zoom 6 is our bestie if we want to just get it back to a normal screen. Okay? If I want to sketch this, I need some points off of it, right? So you could make your own table, or you could go like this. The second button. Graph, because what's above the graph? Table. And it gives you a table. Now, if you arrow all the way up and arrow all the way down, it will never stop. Please don't do that. You're going to have to hold it for 800 years to get it back. So don't be that person. Trust me, it just goes on for a long time. Don't be that person. Okay, so we're going to plot some points off of here. If you arrow up, you'll go to the negatives. If you arrow down, you go to the positives. Obviously, we don't need to arrow very far because our y's are substantially large really quickly. Why are our y's substantially large really quickly? Because you're taking that x value and you're cubing it, right? So x cubed, so 1 cubed is 1, negative 1 cubed is negative 1, 3 cubed is 27. So like they're growing huge. They're growing fast, not exponentially, but cubically. So if I do this graph, on your table it says 0, 0. It says 1, 1. It says negative 1, negative 1. And then it says 2 and 8, and negative 2 and negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I can sketch it. the help of my calculator, right? Okay. What's my leading coefficient? What's the coefficient, the number in front of my largest x? It's just a positive 1. What does that tell us? It ends up on the right. And because it's an odd function, it's degree 3, it ends down on the left indirectly. Because they have to end in opposite directions, right? So the positive means it ends up on the right. Boom. Indirectly, that means it ends down on the left because it's an odd function that arrows are in opposite directions. Okay? What's my y-intercept? My y-intercept is just the constant. And there is no constant at the back, so I could put a plus 0. We agree? So my y-intercept is just 0, 0. That's my domain and range. X such that x and m are the reals. And my range and it's because the arrows are in opposite directions. You can do disco with your arms in the very end, right? If you can disco with your arms in the end, it's XER, YER, unless it's a word problem. Word problems throw everything for a loop, okay? Now, the thing with squareds and cubes, so degree 2 and degree 3, is you could have max and mins. This one has no max or min. Max and mins are where it curves, like if I had a graph like this, that's a cubic as well. This would be a max. This would be a min. And I could find them off my calculator. We agree? But this cubic function that I have doesn't have a max or a min. It just curves through it, doesn't it? There's no like high point or low point. If I tried to use second trace max or second trace min, it wouldn't give me anything. When it does this weird little S shape through it, this is neither a max nor a min. This is called a point of inflection. It's where the graph inflects. It switches direction. But it does not make itself a max or a min. Just a point of inflection. Okay? So I'm going to give you another equation, and you are going to graph it and then tell me all the things about it. P of x equals x cubed minus 2x squared minus x minus 2. So this P of x is just function notation for y, right? That's where your y would be. So if you go type in your calculator, you still type it in as y equals x cubed minus 2x squared minus x minus 2. You have to type it in the way you say it. So are these minus signs or negatives? Minus signs. Because you go x cubed minus 2x squared minus x minus 2. If you put them in a negative, it's going to give you something wrong. If there was one of those signs in front of the x cubed, that would be actually a negative, and you'd have to press the negative button. Okay? So you put them in the way you say them. I want you to sketch the graph. I want you to give me the leading coefficient. What does it mean? I want the y-intercept. I want the domain, the range, and I want the max, and I want the min. These you will use your calculator to find them. If there isn't a max or a min, then it would be a point of inflection. This one has max and min. So try this out. Okay. Oh, put down your marker. Okay, we're going to go to y equals. We're going to type the equation in. It is x. I'm going to clear this out. Clear. Okay. So we are going to go x cubed. If you have one of these calculators, you need to arrow over to get it to go back down. Minus 2x squared. I just pressed negative. Is that okay? Will it still work? Yeah. So minus 2x squared minus x minus 2. Yeah. Now, at least the 10-10 window will get you something. Sometimes the max and mins are off of that window, right? Then you have to go to your window and adjust it, because you can't calculate anything on the screen unless you can see it. So if you're like second trace max and you can't actually see the maximum, your calculator can't actually find it, okay? You have to be able to see it in order to calculate it. We can. So this is our little maximum here, this little point down here. So we want to find it. If we want to calculate anything, we do second trace. Why do we press second then trace? What's the word behind trace? Calc, and we want the calc. We want to calculate something. We want to find the maximum, so I'm going to pick number 4. Now it says down here left bound. Left bound is an instruction. It's an instruction for you to go to the left bound of the maximum on the left-hand side. I'm there. I could hit enter right now because I'm on the left. I could hit enter now. I could hit enter now. I just need to be on the left of it, correct? So there's not just one spot. So I'm going to go here. Sure. Hit enter. Now it says right bound. So now I need to be on the right-hand side of it. I'm not going to arrow all the way to the very top. I literally am just going to get to the right-hand side of it and hit enter. And then it says guess. Well, you have to hit enter for it to do its work. So it has a maximum at negative 0.215251 and negative 1.887388. So negative 0.22. Negative 0.22, and what was the other one? What was the other one? I can't hear anything anyone's saying. Okay, so that means you didn't find it. So go to your calculator, second trace, so one person found it. That's wonderful. Now the rest of you need to as well, because they're not going to help you on your test. So you're going to go to your y equals, and you are going to do second trace what? Maximum. And then you're going to go on the left side. You're going to go on the right side. And you're going to hit enter. And then you're going to see the same thing. And if you don't, you messed up. Okay? Now, this is my answer currently. And currently in my calculator, if I type X over and over and over, this is what it thinks the decimal is. If I type Y, that's what it thinks the decimal is. Okay? So if I wanted to see if I could possibly turn those into fractions, this is what you do. You'd go second quit, and you'd put down your marker first because it's doing diddly squat because it's writing on it. Okay, you'd go second quit, and we're on our screen, right? It believes the X is those crazy decimals. It believes the Y is that crazy decimal, correct? Well, let's see. X, press the X button, enter. Oh, it's the same crazy decimal, isn't it? Math, enter, enter. Doesn't turn it to a fraction. But if it could turn into a fraction, would it at that point? Yes. And then alpha 1 is y. There's my decimal. Math, enter, enter. No, doesn't turn to a fraction. But that way, if I do have a fraction answer, it can become 1, right? Or if you just want to be able to see your x and y on your screen so you can like save them, and use them for something else, you can just pull them up that way. Yeah. Yeah, usually, but honestly, majority of it is multiple choice and numeric. So the only concern for me is if the answer is in fraction form, like say in a numeric, but your answer is in a decimal, you can't do that, right? Multiple choice wise, you're fine because you could turn all the answers into decimals, match your decimals, and decimal love circle. Yay. Yeah, for me, I'm not that big of a stickler on it, but yeah. And then we want to do the minimum. So second trace min 3. Enter, I need to be on the left side of it. Enter, I need to be on the right side of it. Enter, enter. So 1.55 and negative 4.63. 1.55 and negative 4.63. 1.55 and negative 4.63. Okay. The domain is XER. The range is YER. Why? Arms are in opposite directions. You can do a disco. If you can do a disco, you got XER, YER, and that's the word problem. The y-intercept is what in this case? My y-intercept is -2 because the constant is the y-intercept. And constants only occur if there's no brackets, right? If there's brackets, we have to distribute it, collect like terms, then the constant. So the y-intercept is 0, -2. My leading coefficient is +1, which means it's up on right. And because it's a degree 3, that also means it's down on left because they're in opposite places. Okay? So I know I have it's going to be very much of a sketch because those aren't even straight. Okay, so I have a y-intercept at -2. I have a maximum at -0.22 and -4.63. 1, 2, 3, 4.63. Somewhere around here, let's say. 1.55. Wow, I really put the 2 points together when I drew that last one. That's nice. Oh, it's in different colors. -0.22 and -0.819. It's like here. I put the y of the other one with it. 1.55 and -4.63. No. So what's happening, if I wanted this to be more accurate, I'm going to need more points. Where can I get more points from? Your table. I'm not going to be the most accurate. Okay, so it's going to come up, max out, min down, go through. So that graph is perfect, right? Like I have so many points. It's just that is the most accurate sketch you could possibly. No, it's not. I only had like 4 points. I wasn't accurate down. I didn't even have a point down here. I had no points on the right arm. I just sketched. It could go like, or it could go like, or it could go like, all these little options with the noise, obviously, because when you draw, it would do that. You guys are, it's a Friday. I'm doing straight faced. Okay, so make sense? Yeah? Okay. Your homework is going to, ooh, I just about sent my computer flying. That was a mighty sigh for saying homework. Your homework, that's what I got. Okay. And a turning point is just a max or a min, just so you know. So not too many. That may seem like a lot, but it's actually not that bad. Don't know why I just extended the page. I meant to turn my thing off.